So my thesis, concentrated solar power thermochemical device for the creation of biofuel. That sounds quite complicated, so hopefully I'm going to try and break it down. First of all, does the group as a whole, do we know what biofuel or bioenergy, do we know what that is? As the most basic sort of definition, a biofuel or bioenergy is energy or fuel created from plants. So as we have our fossil fuels, coal, oil and gas, that was created by the earth over millions and millions and millions of years. Okay, that took the earth a lot of heat and a lot of pressure to do that. We want to create biofuels using plants that we've grown now, but we want to create them in a few hours. So if you can imagine, to do that, we need actually a lot of heat and a lot of pressure to do this, to turn it into a bio-oil or a biochar, to act like the natural oil and natural chars that we have. So my project is to get that heat and pressure, or that heat specifically, from the sun, and then use that to make the biofuel, bioenergy creation process more efficient. My project is also linked with countries and research groups out in Africa, so I'm also dealing with that within my thesis. So it's aimed to help those in developing countries. So a bit about me and how I got into biofuels. I started materials engineering at Loughborough University. I really wanted to go into oil and gas. I really wanted to be a corrosion engineer, earning the big bucks, and helping fuel that industry. But after the oil and gas sort of market sort of plummeted, I finished my undergraduate degree with 2 job interviews getting cancelled with BP in total. So I decided to do an MSc in mechanical engineering, and then through this I actually learned what biofuels were, and I suddenly realised that biofuels were part of a future, of a greener future, and I sort of learnt how that became much more interesting to be part of a future instead of declining industry. And then University of Leeds, they offered a bioenergy PhD, so that's where I am today. So breaking down my thesis, we have 3 parts really. We have the concentrated solar, that is using mirrors to concentrate the sun's energy onto a certain point. We have the thermochemical side, which is the biofuel creation side, and then we have the end product. So I'm going to quickly try and break them down. So with my project, as I said, it's linked to those in developing countries, and I got sent out to Uganda for 2 months, where I sort of wanted to do a biomass assessment of the country, and I wanted to see how they're using biofuel, biomass, so what sort of plants they're using, what did they have waste, and what energy did they require. So as I went out around the country, this is a load of plastic waste, and I know plastic, it doesn't really constitute as biomass, but at the same time it is waste. They don't have the infrastructure we have here in Leeds. They don't have bin men coming to collect their rubbish, so they just pile it up on the side of the roads, and that's so much plastic, and plastic can be turned into fuel. They require firewood so much, whether it's the cooking process or whether it's at the tea and coffee industry. This picture here was actually taken from the Panga tea processing factory. At any one point, they had 4,000 meters cubed of dry firewood ready to be burnt. And that's so much. This is only a small picture, but this firewood went on forever. So if you imagine that if there was a way of condensing this or making that process more efficient, that would actually save a lot of trees needing to be cut down, or the fuel can be used in other areas. So that was the first idea, was looking at what feedstock was available and what was my end energy process that I wanted to create. So concentrated solar power, there's really 3 main options I can use. We have option 1, which is, it's got an awesome name, It's called the power tower. That is, we've got a big tower, and then we've got loads of mirrors essentially surrounding it. So at any one point, as the sun is over it, the sun hits the mirror, and it's heating up our container at the top, and that can reach temperatures of over 1,000 degrees. And that's just from the sun. We have our parabolic trough technique, which is, if you can imagine, it's like a gutter pipe with a tube running down the middle that will hold an oil or a thermal fluid, and that oil gets heated up to about 400 degrees, and that will be piped off into a heat transfer unit that can boil water to create steam, to create a generator, or we can use that steam directly to transform our biomass into a biofuel. And then finally, we have what look like satellite dishes, like a parabolic dish. So imagine on the side of our house we have our aerials for our televisions, for our sky sets. That's concentrate the sun to a receiver at the end, which again can create steam and then transfer that into our biomass to make biofuel. Then we have to decide what thermochemical technology we want to use. We have hydrothermal treatments, which is the process of using supercritical water, which is water raised to a temperature above 100 degrees, but then because we have pressure on it, it still acts as steam. We have a steam treatment method, which is just really, really hot steam. Torrefaction, which is a bit like roasting. So if we used our steam that we created through our concentrated solar, we could use that to turn a generator to power sort of like an oven. We have pyrolysis, which is heating in the absence of oxygen. Combustion, which is just burning essentially. So if we just burn, say, the plastic, we could create energy through that, just as we have the Viola plant just outside Leeds. Or we have gasification, which, as you can see, is a much higher temperature process. Our different technologies of solar up here was a linear Fresnel technique, which was essentially like a parabolic trough. However, it was all flat panels, and the temperature requirement was much lower. We had our dish system, and we had our parabolic dish, and we had the power tower. The parabolic dish, which was like our sky satellite, because that was a more smaller and more modular unit, even though the temperature wasn't particularly as high, we could use that for more things just because we could group together more satellite sort of modules together. This would make for a more modular design of the overall thesis, and hopefully be used in the developing country. So in conclusion, the idea of my thesis was to create a hybrid between concentrated solar power and the thermochemical technology. Currently, I've got to justify what two technologies I'm linking together. That's sort of where I am at the moment. And then once I've picked my two technologies, I've got to design and test the engineering of the system, and hopefully it can be deployed out in the developing country.